Alright guys, this is the third lesson on prisms, pyramids, cylinders, cones, and spheres. So start off with your heading, skip a line and put the title of the unit. Okay, skip another line, and this is the third lesson, which is on cylinders. Now we have some critical concepts we need to cover first, so skip a line and write this down. Apply the properties of a cylinder, including bases are congruent, volume equals the product of the area of the base and the altitude, lateral area of a right circular cylinder equals the product of an altitude and the circumference of the base. Alright, so those are the critical concepts for this lesson, and we're going to cover each one of those during this lesson. So skip a line, write down your first part of the notes, which is cylinders are three-dimensional closed surfaces. In fact, all of these objects we're going to talk about in this unit are three-dimensional closed surfaces. Okay. Skip a line. The next part of the notes. In general, the term cylinder refers to a right circular cylinder with its ends closed to form two circular surfaces that lie in parallel planes. Okay. And we're going to see a picture in a minute of exactly what that looks like. Now, give me 1 second. Okay. Skip a line. The next part of the notes is that a cylinder is similar to a prism, right? Remember a prism, we take two things like a triangle or a rectangle or a square or a hexagon and we pull them apart so the bases are the same. Well, a cylinder is the same thing, but the bases aren't polygons, the bases are circles, right? So a cylinder is similar to a prism. It has parallel congruent bases, but the cylinder's bases are circles rather than polygons. Okay. Now let's draw a picture in the space below this of a cylinder. Alright. So we don't draw a circle because when we're looking at the cylinder, we're looking at it from its side. So what we draw is more of something that looks like an ellipse. So you just do the best you can. See how that's an ellipse? That's not a circle. Now, I'm going to pull out my ruler, a protractor. Now the sides of the cylinder are straight down, okay? And when we do the bottom of the cylinder, we do the same curve as this piece right here. Okay? It doesn't have to be exact, but it should be curved, just like that. And then to show the curve behind the cylinder, usually we put the dashed line to show that this is the bottom of the circle base. Okay? So that's how you draw a right circular cylinder. Now let's label a couple of things. Remember, this is the top base, this is the circle, so when you go from the center of a circle to the edge, that's your radius, R. Okay? And your height is the length or the distance from one base to the other. Okay, so that's your height. So let's put down here R equals radius, H equals height. Okay? So those are typically the things that either you'll be given in the problem or that you'll be asked to find in a problem involving cylinders. So let's turn this page over. Okay, this is the first thing on the next page. We're talking about volume, all right? The volume of a cylinder can be calculated in the same manner as the volume of a prism. If you remember what the formula was, okay? The volume is the product of the base area times the height, okay, of the cylinder. So here's our formula. Volume equals capital B times H, but remember that capital B is the base area, or the area of the base. So let's write down what's what in this formula. V is volume, capital B is the base area, which is the area of the base, which is a circle, okay, in a cylinder, and H is the height, or the distance from base to base, okay? Because if the cylinder is, say the cylinder's standing up, right, the height is this whole distance here, but the cylinder could be lying on its side like this, and then the height would be this distance here, okay? The bases are always circles, all right? And the height is the distance between the bases. No matter how they draw this cylinder, they can draw it any way they want. But just know that the height is the distance between the bases. And the base area is the area of one of those circles. So, let's keep going. Now, since the area of a circle is pi r squared, right? That's what capital B is going to be. So the formula can be rewritten then. We can take B out and we can plug in pi r squared, because that's the area of the base, which is a circle. So the formula can be simplified to volume equals pi r squared H. Okay? Now, let's draw a picture of this. Give me a second. Okay, so let's just practice drawing another picture of a cylinder. All right, we draw an ellipse. It doesn't have to be perfect. And then we go down the sides. We draw a curved bottom. Just like that. Okay? So, this is the radius. Again, this is the height. Okay? And what you want to find is the area, which is pi r squared, which in our problems we use it as capital B, right? And that's all you need to know for finding the volume. You just need to know the formula V equals pi r squared H. Alright, it's the base area times the height. Okay. So let's go to a new sheet and let's talk about surface area. Put your heading. Okay. Now the surface area of a closed cylinder. So sometimes the cylinder's top could be off, right? Or the bottom could be off. But what we're talking about right now is a cylinder where the top and the bottom are on the cylinder. Okay? So the surface area of a closed cylinder is a combination of the lateral area. The lateral area is all of this area, okay? Around the outside of this. It's all, this is the lateral area, and this are the base areas. So it's a combination of the lateral area and the area of each of the bases, right? We just add them all up. So when disassembled, the surface of a cylinder becomes two circular bases, right? So if we took the top off, it would be one circle. If we took the bottom off, it would be another circle. And the lateral area, okay, imagine we, see if I can peel this off. So watch what happens when I show you what the lateral area of this is. Okay, now just pretend that the cylinder didn't include the cap. All right, and only say that this was the height of our cylinder. Okay, actually, yeah. So the lateral area is a rectangle, and I'm going to show you exactly how that's true. Watch what happens when I peel off this label, which is the lateral area, essentially the lateral surface area of this. Watch what I get. See what I get? I get a rectangle. Okay? So let's go back to our notes for a second. And before I draw the picture of this a little bit more detailed, let's write a few more things down about surface area. Now, the length of the rectangular surface, so the length of this thing, right? Because what we have is so what I did was I took this area and I rolled off the label. So this is the lateral area around the outside. That's the rectangular surface. As you can see, it's a rectangle. And its length, okay, this distance right here is the same as the circumference of the circular base. So if you remember, the circumference of a circle is 2 pi r. Okay. Now I'm going to draw this again, so you don't have to write this yet. And we're going to put it on. It's on the sheet, but I just want to show you while I go. In fact, it's written right here. The circumference of a circle is 2 pi r. So 2 pi r equals the length of this thing. This length is 2 pi r. Now you might be asking you how that's possible. How is that length equal to the circumference of the circle? Well, watch this. If I take this thing back off. It's really important for you to pay attention to this, because this is what most people don't understand. I took this label off of this. Now, what we want to know is what's the length up here? Well, look, watch what happens when I put it back on. The length starts right there, right? And it wraps around exactly the distance of the circle. Right? You see how it wraps on and off that circle? So that circle, that circumference of that circle is the length of this rectangle. Okay? And its height, the height of this cylinder, remember, we're pretending that it's only the yellow part of this cylinder. Its height is from base to base, so it's right here. Okay? So if we wanted to know the area, this whole surface area here, its length, it's one dimension times the other dimension. So the B, which is our area, is 2 pi r times h. Right? It's like length times width. 2 pi r times h. Okay? So let's go back to our thing here. So the length of the rectangular surface is the same as the circumference of the circular base. The circumference of a circle is 2 pi r. So then the lateral area is 2 pi r times the height, or 2 pi rh. That's exactly what I just said. So the surface area of the lateral surface area, right? The lateral surface area is 2 pi rh. Now we still have to add the area of the top circle and the area of the bottom circle, the area of the bases, because the surface area is all the lateral area and then the top circle and the bottom circle. We know the area of a circle is pi r squared. So we have pi r squared and we have another pi r squared, and these circles are the same, right? They have the same radius, they're the same circles. So that's 2 pi r squareds. So look at our formula for surface area. Here's the lateral part of the surface area, 2 pi RH. That's the outside, the wrapper, which is our rectangle, right? Plus the 2 areas of the base circles, 1 pi r squared, 2 pi r squared. Okay? So that long looking formula is the surface area of a cylinder. Alright, now let's draw another picture of this. Okay? So, when we lay this thing out, alright, I'm actually going to use this. Is it going to be? Yeah, this is big enough. Alright, I'm going to use this. You can use whatever you want, a compass or whatever. You just have to draw a circle. Okay? So that's one of the bases, right? So let's write in here base. Base 1 I'll put, little subscript 1, because there's 2 of them, right? And now, when I peel, we have the lateral area of this thing, right? Which was that rectangle. So what I'm going to draw now is a rectangle. This is a picture of me, like if I disassembled this thing, if I took the top off, if I took the bottom off, and if I unwrapped this whole outside area. Okay? So I'm going to draw that rectangle now that I peeled off. So let's say it's about that big. It doesn't have to be exact, right? Let's say it's about this big. So I'm drawing a 2-inch by 3-inch rectangle. Alright, what you draw is up to you. But it needs to be similar to this. Okay? And this is the lateral area. Right? And then we have the bottom also. So now I'm going to draw another circle. I'm going to use this side to draw it just because it's easier, because the bottom has ridges and my circle will be bumpy. So instead I'm just going to use the top one again, because the circles on top and bottom are the same. Okay? And this is base 2. So this area is pi r squared. This area is pi r squared. Okay. And now the dimensions of this thing, remember, this was h. This is our height. Right? If we measured the height of this cylinder. And the length was the circumference of this circle, 2 pi r. That's the circumference of a circle, 2 pi r. So the length of my rectangle, so from there, 2 pi r to here. So that means that my area, my lateral area, is 2 pi r h. Okay? So let's write down here my surface area is my lateral area plus my base 1 area plus my base 2 area, right? It's the sum of all the areas. Now let's just plug in what we have. Surface area equals 2 pi RH is my lateral area, 2 pi RH, plus the area of this circle is pi r squared, plus the area of this circle is pi r squared. And that's where we get our 2 pi r squared. So finally we get back our formula from before, 2 pi RH plus, now this is like x plus x, which is 2x, so it's just 2 pi r squareds. So plus 2 pi r squared. Okay, and that's exactly what we see up here. Okay, let's turn this over and do the last part of the notes. Okay, because sometimes the problems can be a little tricky with surface area. And here's why. Any surface area question must be read carefully because the surface area formula can change depending on the problem. Okay, so write that down and then write this little chart looking thing here. Now there's 3 cases, right? In one case it says, will the surface area include both bases? So if this is a closed cylinder, which is what we've been talking about, it has a top and it has a bottom, okay, then it's the surface area formula that we just talked about. It has a lateral area and it has both circle bases. But there might be a case when there's no top, like if you had a can and the can was open on top, right? So in that case, the surface area would include only one base. So we would still have the lateral area, 2 pi RH, but we would only have the bottom circle area. So only 1 pi r squared would be there. So that would be for the lateral area and one circle base. And then there could be a problem where it's like a tube, right? Where there's no bottom and there's no top, and there's just the lateral area. So then all you would have is 2 pi RH. That's the lateral area only. So those 3 options could be in the problems. Okay, so you have to be careful. They'll tell you, oh, it's an open top can, or it's a can with no bottom and no top, or it's a can with a top and a bottom. So they have to tell you that. Okay? So now let's just draw a picture, a quick picture of each one of these underneath it. So in this one, now we have a cylinder for all of them, right? These are all cylinder problems. So in this one we had both the top and the bottom. And we had always the lateral surface area. For this case, one of the circles is open. So let's say it's an open can. Okay, we'll still have the bottom area, which is where our pi r squared comes in, and then we'll have this lateral surface area still, right? The distance around the whole entire cylinder, which is our 2 pi RH, but we will not have the top. Okay? And for this one, it's more like a tube, right? This one's a little tougher to draw. Well, let's see. Because we got this hidden line thing going on. So let's just color in the lateral type area here. There's just the lateral area. There's no there's no top and no bottom, so there's no top and bottom area. Okay? So now that's the end of the notes. So let's write on those 2 pages 1 out of 2 and 2 out of 2. Now let's go to the problems. Put your name on this. Okay. A right circular cylinder has a volume of 1,000 cubic inches and a height of 8 inches. What is the radius of the cylinder to the nearest tenth of an inch? So let me get my calculator out, because when it says nearest tenth of an inch, I know I'm probably going to have to use my calculator, because it's not going to work out to a nice number. So the formula for volume equals pi r squared h, right? The volume is 1,000 equals pi r squared times 8. Okay, now let's divide first by 8. Actually, let's just divide by 8 pi right away, right? We can get rid of the pi and the 8 and the 8. So what we have is r squared, now watch how I do this, equals 1,000 over 8 pi. I'm just going to leave it like that for now because I'm not really done yet. I need to take the square root of both sides. Right? So the square root of r squared equals the square root of 1,000 over 8 pi. Cross out the square root and the squared, and we get r equals the square root of 1,000 over 8 pi. Now we plug it into our calculator, and watch how I do this very carefully. Square root of 1,000 divided by, and now I'm going to just say 8. Ooh, I got to put my 8 pi in parentheses. See, I almost forgot. Because it's 1,000 divided by the quantity 8 times pi. So it's 1,000 divided by the quantity 8 pi should go in parentheses. Now I also have to put another parenthesis at the end to close that first one that they automatically put in the beginning of the square root symbol. You see that first one? That one has to be closed at the very end. So that's how you're going to type this in. Okay? You do not put 3.14 for pi unless it tells you to. Sometimes the problem says use 3.14 for pi, but if it doesn't tell you, you have to use the pi symbol. Okay? And the pi symbol is right there. You push second, and then you push that caret symbol to get pi. Now we just hit enter, and we got to round to the nearest tenth of an inch, so it's 6.3. So r equals, well, let's put it on the other side because it doesn't matter, right? At this point in our math career, we should understand that we can change the place of the equal sign anytime we want. So r equals 6.3 inches. Okay? Now if you wanted to do this like this, if you wanted to do let's see, 8 times pi, enter, 1,000 divided by answer, enter, shift square root of answer, enter. You could do that too. Alright, but notice how I did the 8 times the pi first, and then I divided 1,000 by that whole thing. Okay, you have to be really careful when you do this because you'll get the wrong answer. Okay? Let's see what happens if I put in, now I don't even want to show you that because I don't want you to do the wrong thing. Just do it how I said because otherwise you'll get the wrong answer. If you don't put that 8 pi in parentheses in the calculator, you get the wrong answer. Which expression represents the volume in cubic centimeters of the cylinder represented in the diagram below? Well, look what they gave us. The diameter is 12, right? Now we know that the radius is equal to the diameter divided by 2. So the radius is equal to 12 divided by 2. So the radius is equal to 6. So be careful because they do this all the time. Our formula wants the radius, right? Pi r squared h. So I had to find the radius first. Not a big deal. So volume equals pi 6 squared times 27. Volume equals, now look, in this problem they do this all the time too. They left the pi symbol in the problem, so they're just simplifying everything else and leaving the pi there. So you're not even putting pi into your calculator, you're just going to leave it there. Okay, sometimes they do that, so you have to know how to do that. All I'm going to do is do 6 squared times 27. So my answer is 972 pi. Okay? Sometimes the answers don't want pi, so then I would just do 972 times pi. Okay? That's the real answer. But you see how it's this decimal thing? A lot of times they would rather you just say 972 pi, because that really is more an exact answer, because otherwise you have to round usually. Alright? So the volume is 972 pi, which is choice 3. And for ours, let's put down our label, centimeters cubed, and our radius was centimeters, and the diameter was centimeters. Okay? Turn this over. Let's go to the next two problems. We have a right circular cylinder has an altitude, which is the height, okay, another name for altitude is height, of 11 feet and a radius of 5 feet. What is the lateral area in square feet of the cylinder to the nearest tenth? Okay. Remember, the lateral area equals 2 pi r h. Right? When we have our surface area formula, it's 2 pi RH plus 2 pi r squared. This was the area of both circle bases. This is the lateral area. So if we had our rectangle, right, if we tore apart the rectangle from the cylinder, this distance is our h, and this distance is 2 pi r h. I mean, whoops, it's 2 pi r. It's just the circumference of the circle. But when you multiply, so when you want to know the area, it's 2 pi RH. Okay? So, let's just solve the problem. Let's call the lateral area LA. Okay? So LA equals 2 pi times the radius is 5 times the height, which is also the altitude, 11. Okay? Now, they didn't put pi in our answer, so that means we're plugging pi into the calculator. So our lateral area, and then we're going to round to the nearest tenth. 2 times pi times 5 times 11. 345.6. 345.6, that's feet squared. Area is always squared. So that would be choice 4. Okay. Let's go back to this first one. I didn't circle my choice, so circle your answer there. Just realized that. Next one. What is the volume in cubic centimeters of a cylinder that has a height of 15 and a diameter of 12? I think this is almost the same as the last problem we did. A little different. So it has a height. Let's draw a quick picture. The height is 15 and the diameter is 12. So the D equals 12 centimeters. Radius equals D over 2. Radius equals 12 over 2. Radius equals 6 centimeters. Volume equals pi r squared h. Volume equals pi times 6 squared times 15. So the volume equals, and look at our answers. They left pi in the problem. So now we just got to do 6 squared times 15. 540. And we just carry the pi next to it, times pi. And that's centimeters cubed. So that's choice 2. Next page. Put your name on top. A paint can is in the shape of a right circular cylinder. The volume is 600 pi and the altitude is 12 inches. Find the radius in inches of the base of the paint can. Express the answer in simplest radical form. Find to the nearest tenth of a square inch the lateral area of the paint can. Wow. Okay, so let's start with our volume equals pi r squared h. The volume is 600 pi, and that's equal to pi r squared, and the altitude, which is the height, right? Let's just put another note in here. The altitude is the height, is 12. Okay? So we want to solve for r. That's the first part. Find the radius. Okay? We're going to divide both sides by pi and by 12. Or by 12 pi. It doesn't matter. It's the same thing, right? I can write the pi first or the pi second. Either way, it's 12 times pi or pi times 12. So that cancels that and that cancels that. So I get r squared equals, now I wrote the pi on the other side here so it just looks better when I cancel it. Let's see what 600 divided by 12 is. 50. So r squared equals 50. Okay. So now to get rid of the squared, we have to do the square root of both sides, because the square root cancels out the squared, and we get r equals the square root of 50. Okay. Now I'm actually going to turn this around so that's a little easier for me, because I don't like it to be on, I like my r, my variable, to be on the left side. And I'm allowed to do that. Okay? So I also want to make that point to you to remind you that you're allowed to flip something in the equal sign. Now, hopefully you remember how to do this. If not, here's a refresher. We take what's underneath the radical and we factor it using a factor tree. So you start with anything that you want. Okay, how about like 2 and 25? And you circle all of your prime factors. That means the numbers that you can't divide any further. Like 2, I can't divide that anymore, so I circle it. 25, I can keep going, so I have to. I'll do 5 and 5. 5 cannot be divided anymore, so I circle both of them. So now I replace under my radical all those factors. 2 times 5 times 5. Don't forget about this 2 that's up here on the left, okay? Just because it's up higher, it doesn't matter. Everyone that's circled gets put back under here. Now everything that appears twice under here, or for every time the same thing appears twice, I cross them out and I bring only one out front. So my radius is equal to 5 radical 2. That's in simplest form, and that's inches, because it says in simplest radical form. Okay, that means you cannot plug this into the calculator. So that's part 1. Then it said find to the nearest tenth of a square inch the lateral area of the paint can. Remember, the lateral area equals 2 pi RH. Lateral area equals 2 pi. R is 5 radical 2, and H is 12. Okay, so now we can plug in pi, alright, because we're rounding nearest tenth of a square inch, so we don't have to worry about simplifying any radicals. we can just plug all of this into the calculator and see what we get. And let's put approximately, because we're going to round. That reminds me, let's go back to that problem where we rounded. And we have to put approximately, right? And I think there might have been another one, so let me look. Yep. This radius was an approximation, because when you round, it's approximate, so you need to put the approximate symbol. Okay, so let's plug it in. 2 times pi times, now watch how I do this, in parentheses, 5 radical 2. Close the parenthesis around the 2, then I have to close the parenthesis at the beginning of the 5, right? For every open parenthesis, you need to have a closed parenthesis. So I have 1, 2 open parentheses, so I have to have 1, 2 closed parentheses, times 12. Okay? And I get 533.1, which is to the nearest tenth of an inch. 533.1, and that is inches squared. Okay, let's look at the next one. The cylindrical tank shown in the diagram below is to be painted. As soon as you see something is to be painted, that immediately means surface area. Okay, look at this. The tank is open at the top, and the bottom does not need to be painted. So we don't need to paint the top or the bottom, okay? Only the lateral area. So only the outside, that's lateral area, needs to be painted. Alright, so what we have is lateral area, remember, is 2 pi RH. Each can of paint covers 600 square feet. How many cans of paint must be purchased to complete the job? So that's our second question. The first one we need to find is the lateral area, because then we can use this to find the number of cans of paint we need. First we need to know the area we need to paint. So the lateral area is 2 pi, R is 12, so times 12, times H is 22. Lateral area equals, okay, now we're going to plug pi in, okay? Because we need to know about what we need here. So 2 pi, you can put 2 pi next to each other like that without the multiplication symbol. It means multiplication, okay? So 2 pi times 12 times 22. Let's round it to the nearest hundredth, okay, just to be safe. In fact, let's just put the whole thing just to be safe. 1658.760921, and that's feet squared. So that's how many square feet I need to paint. Each can does 600. So if I take that total, okay, I'm going to actually round it, so which is approximately 1659 feet squared. So 1659 feet squared divided by 600 feet squared, that's what square feet is, by the way, feet squared, right? Square feet, you could say it either way. Those will cancel, and that will tell me how many cans of paint I need. 1659 divided by 600. 2.765. But you can't get 0.765 of a can, okay? So then I need 3 cans. Okay, you can't go to the store and say I need 2.765 cans of paint. you have to round up. Always you have to round up. Even if it was 2.1, you need 3 cans. Okay, you need more than 2 cans. Now I'm just going to check to make sure that my rounding didn't do anything. So 1658.760921 divided by 600. Okay, see how close that was? So no matter what, you needed 3 cans. So it was okay for me to round there. But you should always check to make sure you get the same answer. So that's it for that one. We're getting there. We got 4 more left. Okay? A cylinder has a height of 7 centimeters and a base with a diameter of 10. So let's draw a quick picture. It's got a height of 7 and a diameter of 10 centimeters. Determine the volume in cubic centimeters. Okay, so the diameter is 10 centimeters and the radius is the diameter divided by 2, so the radius is 10 divided by 2, the radius is 5 centimeters. So our volume is pi r squared h. Volume equals pi 5 squared times 7. And now look, in terms of pi, okay, that means that we leave pi in the answer. So volume equals, we just do 5 squared times 7. We get 175 and we leave pi in the answer. 175 pi centimeters cubed. Okay? Always watch out for that. Now in this one, I'll tell you right now, we don't keep pi in the answer because it says nearest tenth of a centimeter. So I know we're going to be putting pi into the problem. Alright, so the volume equals pi r squared h. It says the volume of a cylinder is 12,566.4, and that equals pi. R is what we're looking for, so r squared, and h is 8. So we're going to divide by pi 8, divide by pi 8, pi 8, 8. We get r squared equals 12,566.4 divided by 8 pi. Take the square root of both sides, cancel that. R equals the square root of 12,566.4 over 8 pi. So R is approximately, watch how I plug this in again, square root 12,566.4 divided by parentheses 8 pi, close the parentheses around the 8 pi and close the first parenthesis at the beginning of the square root symbol. Round to the nearest tenth, 22.4. Approximately 22.4 centimeters. Last two. Put your name at the top. Soda is sold in an aluminum can that measures 6 inches high and 2 inches in diameter. Let's draw a cylinder because that's what a soda can looks like. That's what they're talking about in this problem. It's 6 inches high and it's 2 inches in diameter. How many cubic inches of soda are contained in a full can? Round answer to the nearest tenth of a cubic inch. Well, the diameter is 2 inches, but we don't want that. We want the radius, which is the diameter divided by 2. So the radius is 2 over 2, so the radius is 1 inch. So now volume is pi r squared h. Volume is pi 1 squared times 6. Volume equals 6 times 1 is 6 pi, but we have to round, so let's do 6 pi, and round to the nearest tenth, so 18.8. Volume is approximately 18.8 inches cubed. Okay? Remember, if you need to leave the answer in terms of pi, it will say that in the problem. So this one said round to the nearest tenth. Okay, one more. Happy Brand peanut butter is sold in different size cylindrically shaped jars. While buying a larger quantity of an item usually means a reduced unit price, purchasing larger jars of peanut butter does not always mean a savings. Use the following information to choose which is the best buy. So, large jar, (7 inches) tall, diameter is 5 inches. So, diameter equals 5 inches, radius is diameter over 2, radius equals 5 over 2, radius equals 2.5 inches, right? Now let's keep going with this. The volume is pi r squared h. So the volume is pi 2.5 squared times 7. So the volume is approximately, well, let's leave, no, we can't leave pi. Okay. Let me think here. Diameter. We're going to leave pi for now. 2.5 squared times 7. 43.75, and since we're leaving pi for now, we're still equal. 43.75 pi inches cubed. So, and it costs $7.50. Okay, so let's figure how much it costs, how much you get for 1 cent, right? So let me see here. Well, let's figure out the other one first, then we'll worry about the price. So we have a smaller jar, right? And it's 4.5 inches tall, and it has a diameter of 3 inches. Okay? So, same thing. D equals 3 inches. R equals D over 2. R equals 3 over 2. R equals 1.5 inches. Volume equals pi r squared h. Volume equals pi times 1.5 squared times 4.5. So the volume is, and I'm going to leave pi in the problem, 1.5 squared times 4.5. 10.125 pi. Okay? Now to figure out which one's a better deal, we can do this really in a lot of different ways. Okay? Let's do it this way. We get 43.75 pi inches cubed, but yeah, alright, let's just put it. We get 43.75 pi inches cubed in our container. And that's equal to $7.50. So let's find out what we get for 1 inch cubed. Okay, in both containers, if we figure out how much it is for 1 inch cubed, then we know which one's the better deal. Okay, that's one way to do this. So we're going to divide both sides by 43.75 pi because we want this to be 1 inch cubed. But what I do to one side, I have to do to the other side. So I divide this by 43.75 pi. Okay? So on the left, it's easy. I get 1 inch cubed equals, and now I divide this out. 7.5 divided by, in parentheses, 43.75 pi. Don't forget your parentheses. So let's round to the nearest tenth. So 0.05. So it's 5 cents, okay, for 1 inch cubed. Now we do the same thing over here. We have, this time we have 10.125 pi inches cubed equals $1.99. So we're going to divide both sides. We want this to be 1 on the left, so we're going to divide both sides by 10.125 pi. Those will cancel, and I will get 1 inch cubed equals, well, we should change that to approximately, right? It's approximately, because we're going to round. I do 1.99 divided by, in parentheses, 10.125 pi. And I get 0.06 cents. So, if I buy the large jar, it's only going to cost me about 5 cents for a cubic inch. If I buy the smaller jar, it's going to cost me about 6 cents for a cubic inch. So my better deal is to get the same amount for the lower price. For every 1 inch cubed, I get it for 5 cents rather than 6 cents. So the best buy is the large jar That's it. Doesn't say to explain why, it just says choose which is the best buy, and I showed my work, okay, which is all you have to do. If it says explain, then you would have to write an explanation saying because for 1 inch cubed of peanut butter in the big jar, it only cost me about 5 cents, and for the same amount, 1 inch cubed in the smaller jar, it cost me about 6 cents. So you would have to write that out if this said explain, okay, or justify. But it doesn't say that. So that is the end of that. Now we just have to put our, there's 3 pages, right? So we have to put 1 out of 3, 2 out of 3, 3 out of 3. And that is the end of the lesson on cylinders.